Hey everyone, Mr. Armitage here again, and in this video we're doing the Check Your Understanding from April 30th, that assignment, so you can check your understanding. All right, so this was the assignment, Are You Getting Enough Sleep? Now, as we saw in class when we did this assignment, right, statistically speaking, no one failed to reject the null hypothesis, right? Every single class period, we had the conclusion that our sample supported the idea that Provinstat students got less than 8 hours of sleep on average. You'll have to go check the class notebook if you want more specific results. But now let's go ahead and do our check your understanding, right? This is for a significance test for mu, for the population mean. Okay. So, according to the AAA Foundation for Traffic Safety's American Driving Survey, that's a lot, U.S. drivers spend on average 51 minutes behind the wheel each day. Sounds terrible. A researcher believes this is an overstatement. To investigate, a random sample of 75 drivers were selected. The study revealed that the mean time behind the wheel for the sample of 75 drivers was 46.4 minutes, with a standard deviation of 18.8 minutes. Is there convincing evidence that the mean time behind the wheel for all U.S. drivers is less than 51 minutes? Okay, so let's pull out some key pieces of information, right? So first part is this, on average, spend 51 minutes. Okay, we can see here, right? Our final question, is there convincing evidence that the mean time is less than 51? We see that we have a sample of 75. Okay. And within that sample, we have a mean of 46.4 and standard deviation of 18.8. Okay, let's grab our information. Okay, so here we are, right? The parameter of interest. So state, what are we finding? Okay. Well, okay, we're talking about means, right? Average, mean, right? All these words for the same concept. So we're going to be finding something about a population mean, okay? Some statement about that. So our parameter, true mean time driving, okay, behind the wheel. So that means our hypotheses, right, are going to be about the mean. There we go. Okay, so with that, or sorry, I didn't mean to put the colon after the mu there. So what do we do here? How do we determine what to actually use for the hypotheses? Okay, well, one of the easiest ways is to actually read, right, the last question, the research question, the question that's being asked of us, right? Is there convincing evidence of this thing happening? Okay. Less than 51 minutes. Okay. So is mu less than 51, which would mean that our null would have to be equal to 51 minutes. Okay. That less than tells us exactly what our alternative needs to be. Okay. Now the statistic is going to be X bar, right? That's the information we actually found, okay? So that's the 46.4 minutes. Okay? Notice how that did not enter into our hypotheses at all whatsoever. Sample, totally separate. our alpha level, right, stated at the very end, 1%. Okay, 0.01. Right, plan, name of procedure, right? We have a one sample t-test. Okay, check our conditions, right? First one, random. Okay. Do we have a random sample? Yep, random sample, states right there. Okay. And we'll say, we'll write it out, okay? Random sample, there we go. All well and good there. Okay. Do we meet the 10% condition? Okay. Well, we're really asking if 75 drivers is less than 10% of all drivers. And yes. Okay. Third, normal / large. Okay. Well, 75 is bigger than 30, so we're good there. Okay. So we got a lot of information here, right? General, specific, our work. Okay. Those are largely carryovers from our confidence interval days. Okay. But ultimately, right, we need our test statistic. Okay. That's easy enough to find. Right. Technically, this wouldn't be the general, but this isn't an AP class. We don't have to be super picky about it. X bar minus mu over our standard error. Okay. Now notice we have not calculated our standard error yet, so we're going to need to do that. Okay. So really it's x bar, it's mu naught over, sx divided by square root of n. Okay. Just kind of put everything in it all at once. Okay. So the specific version, okay, will give us 46.4 minus 51 divided by, now what's our standard deviation of our sample? Okay, 18.8. 18.8 divided by the square root of 75. Okay. Now, if we put that all together, okay, into our calculator, right, make sure to put parentheses around your subtraction because the calculator will not understand that that's what you want to do. Divided by, okay, 18.8, and I'm also putting parentheses around the denominator. Okay, when you're dealing with fractions, it's just good practice to do that. Yep. So t is negative 2.119. Okay. Oh, which is our test statistic, negative 2.119. Additionally, we could have done our t-test, right? So stat tests, right? Slow down a second and do that again. On the 84, stat, tests, t-test. Okay. On the nspire, menu, statistics, stat tests, number 7, t-test, number 2. Now we're dealing with stats here. Okay, our mu naught, so our null, well, not the null hypothesis, but the hypothesized value in general, okay, is 51. Our sample is 46.4. SX, so our sample standard deviation, right, was 18.8. Oops. And our sample size was 75. Okay. And then our our alternative hypothesis, right, is that mu is less than that value. So here on the 84, that is already selected, but on the nspire, I have to manually select it right there. Okay. Then I can press OK or calculate and enter. There we go. Okay, we see we got the same test statistic there. Okay, but the p-value, can you see there? Nope, can't. Okay, so I'm going to take away, well, I can't take away the camera. I'm going to have to look right under there. Okay, right below the calculators. Okay. 0.019. Okay, rounded. Right. So our conclusion, right? So because our p-value is greater than our significance level, right? 0.019 is greater than 0.01. Okay? We fail to reject. I'm going to use a couple of abbreviations here because I'm running out of time before the bell rings. Okay, we fail to reject null, which means we don't have evidence, okay, or convincing evidence that, you know, the mean drive time of adults is less than 51 minutes. Okay, there's your answer for that. Okay, I hope that this helped you, or at least you could check your answers, and we'll see you in the next one.